Dear students, in last class I have explained important topic of this particular chapter, which is dimensional formula. So, what is a dimensional formula? A formula in which a physical quantity is expressed in terms of the fundamental quantities is called dimensional formula of that particular quantity. And we have studied important dimensional formula of few physical quantities. So, very quickly we will revise, because we are going to use this dimensional formula in today's discussion. So, first, the dimensional formula for all the quantities that we have discussed, starting with area. What is the dimensional formula of area? It is L square. After that, volume. What is the dimensional formula of that? L cube. Density, ml to the power minus 3. Then velocity or speed, which is Lt minus 1. Then we have momentum and impulse, which is mLt minus 1. L square, L cube, ml to the power minus 3. Then Lt minus 1, mLt minus 1. So, remember all these dimensional formula, only then you will be able to understand our next topic. Then one more list. Acceleration, Lt minus 2. Force, weight and tension, mLt minus 2. Acceleration is Lt minus 2, force is mLt minus 2. Work energy, ml square T minus 2. Pressure and stress, ml minus 1 T minus 2, and finally the power, which is ml square T minus 3. So, only by going through this dimensional formula again and again, you will be able to remember this, and that is what I am going to use in our topic. Okay. Now, what are the two important uses of the dimensional formula? First one, checking the correctness of a given equation, and the second one, deriving the relation between different physical quantities. So, let us learn more about it. So, the question is, check the correctness of the following equations. Now, how to check the correctness of an equation? So, there is one question that has appeared in the exam 2016, and the given equation is V is equal to V naught plus Et. So, later again you will be familiar with all these terminology, okay, as what is V, what is V naught, what is A, what is T, but timing I will explain what are these terminology. Okay. So, in the exam it will be given as what is V naught, what is A, what is T. V is the velocity, this V naught is also velocity, A is the acceleration, T is the time. Okay. So, moment an equation is given, do write the equation and then immediately write the dimensional formula of it. Okay. What is the dimensional formula of velocity? Lt minus 1. What is the dimensional formula of this velocity? Same thing, Lt minus 1 plus. What is the dimensional formula of A, acceleration? Lt minus 2. Time, dimensional formula of time is T. Simplify this, Lt minus 1. Right as it is, Lt minus 1, no changes here. But here you have to simplify. Lt minus 2 plus 1, minus 2 plus 1 is minus 1. So, we get Lt minus 1. Now, there is a principle that is called principle of homogeneity of equation, which states that the dimensional formula of every term in a given equation must be same. According to the principle of homogeneity of equation, dimensional formula of every term, see, this is one term, this is another term, this is the next. So, only then the given equation is dimensionally correct. Now, check this. Every term, we do not add here, okay, do not add Lt minus 1 plus Lt minus 1 becomes a 2 Lt minus 1. No, we do not add. We just write the dimensional formula of every term, and we find that the dimensional formula of all the terms in this equation, that is here, same thing, is same. So, therefore, we have to write dimensional, dimensional formula of all the terms is the same. Therefore, given equation is dimensionally correct. So this is the conclusion. This is how we check the correctness equation, So how to check whether the given equation is dimensionally correct or not? By writing the dimensional formula of every term, and if you find all the terms of that equation, if they have same dimensional formula, then that given equation is dimensionally correct. I hope you understood. So very simple. It's either a 2 mark or 3 marks question. Okay, it has appeared once in the exam 2016. So this is the method. So write the equation, write the dimensional formula, and check if all the terms are same. Suppose if all the terms which are there, if they have a different dimensional formula, if the dimensional formula is not same, then we write dimensional formula for all the terms is not the same. Therefore, the given equation is dimensionally incorrect, dimensionally not correct. So that's what you have to write at the end. This conclusion is important. Okay, writing this statement is important because we are verifying it. We are checking. So therefore, what is the inference that we have to write at the end? Okay. So one more question. One more equation, and you all are familiar with all these equations, right? So let me write the next. The next is S is equal to ut plus half at square. This is the equation, and we have to verify. We already know that this equation is correct, so that's why automatically we can prove that this equation is dimensionally correct. But still we'll prove. Okay, so what is the first step? Writing dimensional formula. What does S stands for? S stands for here displacement. Displacement is a measure of length. So dimensional formula is a L, length. U, velocity, whether it's initial velocity or final velocity, the dimensional formula remains the same, which is Lt minus 1. Then time t. Now look at this. This half is a number, number has no dimensional formula. So whenever you find a number or a constant, don't write anything, don't write half here. Okay, don't write half, because it's a number, no dimension, because we are writing the dimensional formula. Okay, that's why if there is a number, just ignore it, leave it. Okay, what's say acceleration? Dimensional formula Lt minus 2. See how easily I am writing, because I am very familiar with these dimensional formula, and even you will be able to write it provided you know the dimensional formula for all those terms which I have given, table, correct? So that's important. Then t square, time square, t square, so t square. So simplification is important. So write L is minus 1 plus 1 will get cancelled, right? So what we get is only L plus, here also minus 2 plus 2 will get cancelled, right? What do we get? Only L. So what do we get to see? The dimensional formula of all the terms in the given equation is same. Therefore, the given equation is dimensionally correct. So hope you understood how to check the correctness of the given equation. Okay. So let's go for one more equation that has appeared in 2019, and the equation given is a V is equal to V naught plus AT square. See, V is equal to V naught plus AT. That is the actual equation, we know it already, right? But here V is equal to V naught plus AT square. So what do you think of this equation? Is it correct or it's incorrect? So definitely it is incorrect, because by looking at the equation we can say that. But we have to prove it, right? We can't just write one statement. So because it's a 3 marks question, so let's write the dimensional formula. Velocity Lt minus 1. Again velocity Lt minus 1 plus acceleration Lt minus 2. Square of the time t square. First term Lt minus 1, second term Lt minus 1, third term minus 2 plus 2 will get cancelled, we get L. Now look at the dimensional formula of every term. Is it same? Definitely not. See, here there is Lt minus 1, here there is Lt minus 1, and here there is only L. So, what is the statement you need to write? The dimensional formula for all the terms are not same. Therefore, the given equation is dimensionally what? Incorrect. So, that is what you have to write. Understood? Okay, so some more example. Half mv square is equal to mgh. Okay, slightly different equation. Half mv square, half mv square is equal to mgh. So, half mv square, you note it's a kinetic energy. Mgh is nothing but the potential energy, formula for potential energy. Again, not to worry, what is important is the term. What is m? Mass. Half is a number, we don't write that. M, mass, so write m. Square of the velocity. So, first you write velocity Lt minus 1 and then square, important. Okay. Square you write outside. Again m, mass. What is g here? G means it's acceleration due to gravity. Acceleration due to gravity has the same dimensional formula as that of acceleration. So, which is L t minus 2. H height. Height is a measure of length. So, I have to write L. Okay. So, here it is m. Now, apply this power to this every term. L square t minus 2. Correct? No, minus 1 into minus 2. That is equal to m L into L square t minus 2. So, conclusion, same dimensional formula for all the terms. So, that is why given equation is dimensionally correct. So, one more equation, it is called Einstein's mass energy relation is equal to mc square. Okay. So, Einstein has already proved it. So, we do not have to verify again, but still dimensionally we have to verify. E stands for energy, work, ml square t minus 2. M is the mass here, m. C is the velocity, speed of light. So, speed means the velocity, Lt minus 1, the square. So, m L square t minus 2, m L square t minus 2. So, proved that given equation. Statements you need to write, do not leave it like this only. Okay, you will not get marks unless you write that statement here. What is the statement? All the terms of the given equation, they have the same dimensional formula. That is why given equation is dimensionally correct. So, one more equation. F is equal to mv square by r. Okay. Where F is force. So, force dimensional formula mLt minus 2. M mass. Velocity Lt minus 1, square of it, by radius. Radius is a measure of length. So, that is L. Since it is the denominator, I am writing it. Okay. According to the equation, write the dimensional formula. So, on the left hand side we have m, L t minus 2, m, this is L square t minus 2 by L. So, simplify again, ml t minus 2, m, L square by L, you will get only L, and then t minus 2. Again, same dimensional formula, given equation is dimensional correct. So, therefore, out of this, the entire list, only the third one is dimensionally incorrect, the rest of all the equations are dimensionally correct. Okay. So, this is how we check the correctness of the equation. Hope I have given enough example for the first application of the dimensional formula. Let us go for the next one, next application. What is the next application? The next application is deriving the relation between different physical quantities. For that, one example is given here. Okay, right. So, we are done with all the checking the correctness of the equation, those type of problem. Now, this is the illustration example for the next application. The time period of oscillation t of a pendulum is found to depend on. So, they have given there is a quantity called time period. So, whenever they give such quantity, do write like this, the given T, okay, right, T given quantity, okay, found to depend on, option A they have given, what, length of the pendulum. So, since it dependent, write directly proportional to, this is the symbol L, L means length. See, whenever one quantity is dependent on the other, there will be some power for it, power. That power can be 1, power can be 2, power can be half, power can be minus half. For example, kinetic energy, you are familiar with it, right? Half mv square. So, what is the power of m? It's a 1. What is the power of v? It's a 2. Correct? So, there are different powers are there. If it is square root, the power becomes half. If it is in the denominator in the root, then it becomes minus half, minus 3 by 2. So, various powers are there. So, that is not given here, and it's our job to find that power. So, that's why T proportional to L, you write to the power x, and we have to find that x. X can be 1, x can be 2, x can be negative. So, what do you mean by positive? If x is positive, then the time period is directly proportional to the length. If x is negative, then it is inversely proportional to the length. Inverse means it comes in the denominator. Okay. So, that is what we have to derive, because they have asked, right, derive the relation. They will not give the ready-made equation. Our job is to find what is the power, whether the term comes in the numerator or in the denominator. And if it is in the numerator, what is the power of that? If it is in the denominator, what is the power of it? So, that is why I have given it as x. So, x is unknown, which we have to find it. Okay. All right. Next. So, that is one factor which is given very clearly. The second factor, it depends on the acceleration due to gravity g at a place. So, write along with it, second one, g. Here I have taken x, now I will take y. Okay. So, what is the basis to write this? Because it is a given. The time period depends on the length, and we do not know the power which we have to find. Time period depends on acceleration due to gravity. Again, power, I have written it, which we have to find. Are you clear? So, now let us read the remaining question. Derive the relation between physical quantities using the dimensional formula or dimensional analysis. What is the relation between T, L and G? This is what we have to calculate. Okay. So, now listen carefully and then see. So, remember, for the coming exam, the question will be of these type, 5 marks question. So, whatever that I am explaining right now is a 5 marks question. Okay. Derive. So, you have to write all the steps one after the other. So, that is why listen carefully. This is an important question. Right. So, T proportional L to the power x, G to the power y. Proportionality symbol, we replace it by a constant, see, is equal to k, where k is a constant. L to the power x, G to the power y. So, I will write where, and I am going to consider this as equation 1. Okay. So, where what is k? It is constant of proportionality. Okay. Where what is k? Constant of proportionality. Normally, they do not give that constant of proportionality. So, you can leave it as it is at the end, because if it is given, then you can write it, otherwise write it as k. Okay. So, I will tell you what exactly you have to do it, right. So, now once you write this equation 1, write the dimensional formula of every term like this. Write the dimensional formula of every term. So, let us start from here. What is a T? T means a time period. So, what is the dimensional formula of time? That is a T itself. K. This K is a constant of proportionality without any unit, without any dimension. So, that is why K is a constant. So, that is why I am not going to write any dimensional formula for that, because there is no dimensional formula for that constant. So, do not write anything. What comes next? L. What does L stands for? Length. So, what is the dimensional formula of the length? L itself. So, write L. What is the power for it? The power is x. L to the power x. G, what does G stands for? Acceleration due to gravity. Acceleration. So what is the dimensional formula of that acceleration? It's a L t minus 2 to the power, what is the power here? It's a y. Correct? So that is the power. Understood this now? T here for this constant, no dimensional formula. L to the power x and G to the power y. So let's further simplify this. T is equal to L to the power x. Correct? Then again L to the power y. T to the power minus 2y. Okay. Now let's further simplify. T is equal to L to the power x, L to the power x, L to the power y. So there is a L having power x and y. So therefore this becomes L to the power x plus y. That is the theory of indices. Correct. So we have to add the power for L. For T it is T to the power minus 2y. Okay. Now look at the equation. On this side, we don't have m, we don't have L, we have only T. And what is the power of T here? It's 1. So now if I compare, because equation has to be dimensionally correct whenever we derive the relation. So therefore, this equation which is there, I can write like this, m to the power 0, because m is not there. L to the power 0, because L is also not there, because L to the power 0 is 1, m to the power 0 is 1, and then T to the power 1. That's equal to L to the power x plus y, T to the power minus 2y. So since this equation is dimensionally correct, now you can compare the powers. What is the power of L? X plus y. What is the power of L here? It's a 0. Therefore, x plus y is equal to 0. X plus y is equal to 0. Okay. Compare the power of T. Minus 2y. Minus 2y. T is equal to what? Power here is 1. Therefore, what is the value of y? Minus 2y is 1. So, what is y? It's minus and then half. Bring this 2 here down. So, minus this side. So, we get minus half. So, we have found the value of y. Once we have found the value of y, I can use that here, to find the value of x. So, x, let me write here, x, which is this. What is the value of y? Minus half. Minus half. X minus half is equal to 0. So, what is the value of x? The value of x is half. So, finally, we have found the value of y, which is here. We have found the value of x, which is here. And now it's a time to substitute in this equation. Come back to equation 1. In 1, t is equal to k, which is a constant. Then L to the power x, which is plus half, L to the power x. L to the power x is half. Then g to the power y. And y is minus half. Minus half. See, you have to write so much. This is a 5 marks question, right? Hope you are following. Then, this is not the end of it. We have to continue. T is equal to k into L to the power half. And since g has a negative power, take that term to the denominator. Divided by g to the power half. Because g to the power minus half means it's in the numerator. So, in the denominator it will be g to the power plus half. Now, tell me what is the meaning of L to the power half? L to the power half is nothing but square root, correct? So, therefore, you can write t is equal to k into square root of L by g. L by g. So, this is what the final expression. And keep in mind, that constant k, we won't be knowing it actually, correct? If they give, then do write it. Otherwise, you can stop till here. The value of k we can find only by experiment, and in this case the value of k is found to be 2 pi, and that is why t is equal to 2 pi root of L by G. So, writing that is optional because you will not be knowing the value of k. So, it is enough if you write only till here in the examination. Have you understood this particular derivation? So, I have given one example. I will give you two more illustrations so that you can understand this derivation still better. So, let us go through one more question and one more illustration for deriving the relation between different physical quantities. So, the next question that is given, see here the question is given in a slightly different way. Here already they have given derive k is equal to half mv square. In the previous question it was like this, time period depends on the length, the time period depends on the acceleration due to gravity, but here it is given that k, where what is k? Kinetic energy, what is m? Mass, what is v? Velocity. So, we have to derive this. And that, can you see that constant of proportionality already given, what is the value of it? It is half. Therefore, now look at the steps by which you have to start. What is the equation that we have to derive? K proportional to, which is the first term on which it depends on the mass. Write the power as x. And we already know the power here. See, what is the power that we get for m? It is 1. That is what we have to prove. Clear? Then k proportional to m to the power x, which is the next variable v, velocity to the power y. Even though the power is given, do not write that power here. You have to consider as an unknown that we do not know. Are you clear with this? So, first k, kinetic energy, depends on m, half is a constant, is a constant of proportion, and then depends on v. Write like this. What is the next step to write? K is equal to, capital K it is, okay, capital K is equal to constant of proportionality small k, which is given, see, half is that this k, m to the power x, v to the power y. Okay. Whether it is in the numerator or denominator, always consider in the numerator only, m to the power x, v to the power y. Clear? Right. So, this is first equation. So, tell me by the end what we have to get the value for x and y. It is already there, right. So, we should get m equal to 1 and the value of y equal to 2, that proves our equation. So, this is a different way of asking the same topic is the same, but here the equation is given directly. Okay. In the previous question we have to derive the equation. The equation is given, you prove it that k is equal to half mv square by the method of dimension. Okay. Yes, so let us continue. First k, energy, we have tried the dimension formula. Any form of energy or work is ml square t minus 2. K, constant, no dimensional formula for it. Next, mass m, power is x. Velocity, dimensional formula Lt minus 1 to the power y. So, simplify, ml square t minus 2 is equal to m to the power x, L to the power y and t to the power minus y. Now, compare the power, power is 1 here, when we write m, it is 1, m is there, right, 1. So, what is the value of x? M to the power 1, m to the power x, so x is 1. Compare the value of y, L square, L to the power y, so y is equal to 2. Even if you compare here, you will get the same, see, minus y is equal to minus 2, therefore y is equal to 2. So, we have found it easily, x is 1, y is 2. So, therefore, now in 1, here in 1, k is equal to k m to the power 1, v to the power 2, correct, m to the power x, v to the power y. And the value of k is given constant or proportion, it's already there, half. So therefore, since k, small k is equal to half, k is equal to half mv square. Understood the derivations, students? So this is how we use the dimensional formula in deriving the relation between different physical quantities. Okay. So one more example to derive the relation between different physical quantities. The equation is F is equal to mv square by r. We have used it, just now to check the correctness of the equation. But here they have asked you to derive. Where what's F? F is the force. What is m? Mass. What is v? Velocity. What is r? Radius. So force depends on how many factors? It depends on 3 factors: m, v and r. So let's write the equation like this. F depends on mass to the power x. It depends on velocity to the power y. It depends on the radius to the power z. Even though r is in the denominator, don't write minus z. Everything in one line. Okay, it's our job to find the power of all this. Whether it's a positive power, negative power, our job is to prove this. So therefore, always write in one line all the dependent variable. Clear? Okay. Next, constant of proportionality k, m to the power x, v to the power y, r to the power z. So this is equation 1. And then do write where what is k? K is a constant of proportionality. Proportionality. Constant of proportionality. Clear? Okay. Next, time to write the dimensional formula of every term. First, force. What to write? ml t minus 2. See, only when you are fluent with those physical quantities, dimensional formula, then you will be able to write it like this. So that's why first study that table. Okay. Practice again and just write n number of times, where n is a very large integer. Okay. Right. So force is over. K, constant of proportionality, no dimensional formula, nothing to write here. After that, m, what's m? Mass to the power x. V, velocity, L t minus 1 to the power y. R is the radius. Radius is a measure of length to the power z. Now combine m L t minus 2. M to the power x, L to the power y, t to the power minus y, and L to the power z again. So club once again ml t minus 2, m to the power x, and L there are 2 terms, no? So y and z, so therefore it becomes y plus z. And then t to the power minus y. So time to compare the dimensions, which is power. M to the power x, here what is m to the power? It's 1, so x is equal to 1. L to the power 1, so therefore y plus z is 1. Y plus z is 1. Next, minus y is equal to minus 2. Minus y is equal to minus 2, therefore y is equal to 2. So we have found the value of x, we have found the value of y, and then now you substitute that here. 2, y is 2. 2 plus z is 1. So what is z? It's 1 minus 2, which is minus 1. So there we are with the x, y and z. Now time to write the equation. F is equal to k m to the power x, which is 1, m to the power 1, v to the power y, y is 2, then r to the power z, z is minus 1, so r to the power minus 1. So now simplify. F is equal to k m v square. R to the power minus 1 means, so bring that in the denominator by r. What is the value of the constant based on this? Constant value is 1, it's a 1 into mv square by r. So therefore, k is 1. It's a given, that's why I am writing it. So therefore, f is equal to m v square by r. Okay. So hope you have understood this particular equations as how we can derive it. So we'll learn more about it. There are a few more things to learn regarding the dimensional formula. So therefore, as you all know, I have already announced the test. So start preparing both the chapter 1 as well as the chapter 2, and all the 5 marks questions, derivations are mainly based on these kind of derivations. Okay. So I will continue rest in my next class. Thank you.